When a software application grows large and complex, development velocity slows down. We often find ourselves dealing with a single tangled code base, a classic monolith. Around this code base, pressure builds up, tests take hours to run, deployments become risky events, and teams constantly step on each other's toes. Changes in one feature cross multiple areas, forcing coordinated releases. To regain speed, we want to decompose this giant system into smaller services. But how should we draw these service boundaries? Instead of looking at technology layers or code files first, we must look at the business domain itself. The business domain represents the entire problem space we are solving. Inside this domain, smaller areas with unique business capabilities emerge. These are subdomains. A subdomain is a meaningful part of the business. It has its own rules, its own expertise, its own vocabulary, and its own reason to change. How do we find these subdomains? We start by analyzing how the organization functions. Look at the departments, business processes, and areas of expertise. Next, we examine the language. Look for key domain objects that change meaning or rules in different contexts, like a product catalog versus inventory. We treat subdomain discovery as an iterative process, not a one-time design. We continuously refine boundaries as we learn more about the business. To refine our candidate boundaries into actual service candidates, we pass them through two classic filters, starting with the single responsibility principle. The second filter is the common closure principle. Things that change for the same business reason should stay together inside the same service boundary. If a single business rule change forces us to modify and coordinate deployments across three services, our boundary has failed and must be rejected. Domain-driven design groups subdomains into three types. First is the core subdomain, the key differentiator and most valuable part of your business. For an online store, core subdomains might be recommendation engines or dynamic pricing. These give us our competitive advantage and must be built in-house. Second is the supporting subdomain. It is necessary for operations but is not a differentiator, like catalog management. We can build it simply or outsource it. Third is the generic subdomain, like authentication or email alerts. These are common needs, best handled by off-the-shelf software. To make this practical, keep a mental checklist. We start with business language, identify reasons to change, and locate where the expertise lies. Then, evaluate team autonomy. Can a small cross-functional team own this area completely? Finally, examine who owns and updates the underlying data. These signals highlight stable business-aligned boundaries. They serve as solid candidates for our microservice architecture, allowing teams to deliver value independently. By mapping subdomains first, we build stable microservices. We avoid technical layers and prevent a distributed monolith where every service is tightly coupled. Always remember the core rule of microservices decomposition. Focus on business value. Define the subdomain first and the service second. To decompose a monolithic system, we first need to step back and look at the entire business as a whole. Customers place orders, restaurants update menus and receive requests, delivery riders coordinate pickups, and administrators manage billing and support. This forms a single long customer journey, starting from food search, ordering, payment, kitchen preparation, delivery, all the way to receipt. In a monolith, all of this code is bundled together. A change in restaurant menus can risk breaking payments or rider dispatch, slowing down team velocity. To find services, we don't start with code. We look at the actual business activities taking place. We identify activities like managing customer profiles, browsing restaurant menus, maintaining shopping carts, and submitting order requests. Then there is authorizing payments, preparing food in the kitchen, dispatching drivers, and tracking the delivery progress in real time. Finally, we dispatch SMS alerts, manage customer support tickets, and process refunds. These are business capabilities, not software services yet. Next, we group these activities into candidate subdomains based on business expertise and operational boundaries. Customer management handles accounts. Restaurant profile management handles restaurant onboarding, while menu and catalog owns food item listings. Order management coordinates the cart and checkout. Payment handling manages credit cards and delivery management assigns riders. Finally, notification handles messages and support and refunds handles disputes. Each area is run by different business experts. To validate these candidate boundaries, we apply the single responsibility principle and the common closure principle. A change in restaurant menus happens when a chef updates prices. This should never force a redeployment of order checkout rules. Similarly, delivery dispatch rules evolve for logistics reasons, like rider availability, completely separate from payment gateways. If we swap our credit card processor, it should only touch payment handling, preserving loose coupling across the rest of the application. Now we classify each subdomain. This dictates where we spend our engineering resources for maximum business value. Order orchestration and real-time delivery routing are core subdomains. They directly differentiate our platform from competitors. Menu listings, restaurant onboarding, and support ticketing are supporting. They are necessary to operate but do not differentiate us. Payment gateways and SMS notifications are generic. We can buy these off the shelf instead of building custom solutions. With these subdomains identified, we map them directly to candidate microservices, creating clean business-aligned boundaries. We place an API gateway at the front. Clients call the gateway, which routes requests to independent, encapsulated services. Services communicate asynchronously using events. When the order service publishes an order-placed event, delivery and notification react. Each service owns its database. Because the boundaries align to business subdomains, independent teams can build and deploy autonomously. Discovering candidate subdomains is just the beginning. Now, we must refine these boundaries to build stable microservices. Which of these candidate boundaries will survive real-world changes? We must test them against cohesion and chain stability rules. Let's put our candidate subdomains through a series of boundary tests to design our target microservice boundaries. First, let's examine the order management subdomain. An order undergoes a series of state changes throughout its life cycle. All of these state transitions and validation rules are highly cohesive. They change for the exact same business reasons, so they must stay together. While payments and deliveries react to these states, they do not own the order state. They are external collaborators. Verifying order is a stable boundary. Next, we test delivery management. This domain deals with physical routing, GPS tracking, and rider dispatch. Rider dispatch rules evolve based on logistics and driver supply. These change independently of food checkout rules, handled by different business experts. Also, live tracking creates massive read and write traffic. Isolating delivery allows us to scale it dynamically without impacting the core checkout system. Now let's look at a classic trade-off: menu catalog versus item availability. Catalog contains food descriptions and photos. Chefs update menu items occasionally. But item availability changes instantly as orders clear. These have very different change speeds. You can keep them together for a simpler MVP. But at high scale, split availability into its own service to avoid locking the catalog database. Let's refine our supporting and generic subdomains: payment handling, notification, and support. Payment is a generic subdomain. We isolate external gateways behind a wrapper adapter. The service itself is just a translation layer. Notification is a generic utility. Support is a supporting subdomain. Decoupling them ensures customer support tickets or emails never block core orders. Now, let's examine data and communication. The golden rule of microservices is strict database ownership. A service owns its tables. Use APIs for direct requests. For state changes, services publish events, like order placed, allowing other services to react asynchronously. Never let services share a database. Direct queries break deployment autonomy, turning your system into a tightly coupled, fragile distributed monolith. This brings us to our refined subdomain-aligned microservice architecture. Clients access the system through an API gateway. The event broker coordinates asynchronous messages, while separate databases ensure each team can develop and deploy autonomously. By aligning service boundaries with business subdomains, we ensure our architecture is stable, resilient, and ready for continuous delivery.